So now we will talk about the integration of EDA with different systems, how we can automate it using the APIs. That is what we call adaptable data center networks. Because the problem that we currently see with most, I think, vendors' software is that it's kind of a black box. We'll talk about the black boxes. In EDA, we try to make sure that we do not have a black box that you have to deal with, and we present you with two sets of apps that you can use. One set of apps, we call them script-based apps. The Fabric, the VNet, the Bridge Domain, the BGP Peer, these are script apps. What does it mean? What's a script app? A script app runs in a constrained environment. It runs within the EDA, within two separate components, config engine or state engine, based on if it's a configuration script or a state script. And these scripts are written in Python, only in Python. You cannot write them in C and Tcl and Rust. No, they are written in Python. Why? You would say that Python is slow and it's not performant. Cool kids do it in other languages. The reason is that these script apps are meant to be scripts, very simple, minimum logic, and leverage EDA API. That means that they do not do heavy computational stuff themselves. They rely on EDA to do computational stuff. And they only call API of EDA to get the nodes, to configure the nodes, to work with labels, to understand which nodes are there. You use these scripts to talk to EDA API, and the heavy computational part is done by EDA itself with performance C and C++ code. So these scripts is something that you can write yourself. And I would say that maybe next hackathon we will have an exercise for that, where you will write one of these scripts and you will be able to create your own version of the Fabric or a different NTP client, something like this. So this is one of the set of apps that you can write. And then these apps will eventually configure something on the nodes or take the data out of them and present you with a state metric like a health. So if you want to have a health of an NTP client, which is not currently there in our app, you can take the NTP client app, enhance it with a state script so that when the synchronization is happening, you can display the jitter, the NTP parameters in the UI as well. So this is all in the realm of possibility. But sometimes you need to go further, and you want to create apps that are much more complex. Typically, these apps are integration apps. Our app that talks to Netbox, for example, and synchronize the pools, it is a controller-based app. And this category of apps is something that is more feature-rich. At the same time, it requires you to write a proper controller-based application. So people who are, again, familiar with Kubernetes, they know that you can use the operator pattern and create those controllers in Kubernetes clusters. And these controllers will run as pods, containers, which means that you can write them in any language. You want to have some COBOL scripts running, you can definitely do that. And these controller-based apps will require you to work with Kubernetes more directly. They will not run in the state or config engine. They will run in Kubernetes natively. And you will talk to EDA API, but you can also talk outside of EDA. You can talk to Netbox. You can talk to cloud providers. You can talk to your own database that you have in your system and fetch the inventory data, for example, from it. So these kind of controller-based apps is what we typically use when we need to write some integration app with ServiceNow, PagerDuty, Netbox, Discord for notifications. These are kind of the apps that fall into this category. And everything in EDA is an app. There is no such thing that, well, there are a few things but that are not the apps, but most of it, like for 90%, is an app. And of course, because it's an app, we needed to have a store where you can install apps. And I think this concept is very unique in a way that, yeah, you can have a store in any other network management system. The way we did it with EDA, though, is quite unique in a way that you use Git for storing your applications, and you use container registry to host them. That means that this store that you see on this slide is not something that is fixed. You can configure your own store. You can create your own store inside your company, and EDA will discover it and make use of it. You can write your own application, publish it in the App Store, and you will be able to see them in the EDA UI. which is quite powerful and quite interesting. I wanted to show you how it works actually. So if I jump out of my slides and go back to my application, so I'm coming back to EDA, I log in. Okay, so we're in the EDA system, and this is where you reach the App Store, or EDA Store. You go to System Administration tab, and immediately you see that there is a list of apps that is available to you. Some of them are installed already, like AI Fabrics is installed. There is Bootstrap application that is installed as well. A bunch of things, like you see the fabrics that we played with, like this right here, filters, interfaces. Even a simple thing like an interface is an app, so you can install it. You can basically create your own version of an interface, an abstracted version of it, publish it to your catalog, and you will see it here. What I will use, I will switch to this all view, which shows me the system menu and the applications all together, because I wanted to show how it works live. So I'm going back to my store, and I will install now a Prometheus app. So the Prometheus app is an app that allows you to stream data from the EDA system towards a Prometheus database. It will create a scraping endpoint, and Prometheus can be configured to scrape from it. Why do we do it? We want to make sure that your existing management tools can get the data out of EDA system. All of this streaming stuff that we can do, we can also export it to Prometheus, so you can leverage your engineering power that maybe or may not be familiar with Prometheus and use other monitoring tools. But have a look at this. So this is the Prometheus exported application. If I click on this, it shows me that this is an app that has been written by Nokia. There is an overview, documentation, blah, 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 and I can install the version 3.0. But look at this part here. When I click install, my Prometheus app will appear in this list of categories. So once my system will go and download this, you see here, it immediately appears. I did not hit refresh. I did not do any of the state retrieval. What happened is that EDA went to the catalog. I click install. It downloaded the container image of this exporter app. It figured out the dependency, what needs to be installed for it, installed it, extended the API of the system, and now this Prometheus app is in my panel. I can click on export. This is my application, that part of the Prometheus export, and I create it. So I do exactly the same as I did it with interfaces, with fabrics, with all the things that we've played with. Now I can configure my Prometheus export endpoint through declarative intent. I can say which export groups I would use, and once I commit it, it will be running live. So the catalog that you could use is absolutely a powerhouse of applications. You will see a lot of applications that we push, but there is also different catalogs that we already use internally. For example, we have a development catalog that our devs push stuff to, so we can configure it in our system and install beta versions of the apps. You can install them. You can create your own catalog. It's just Git and container registry, which is quite powerful. So you're not limited in the EDA catalog that we ship. You can create your own, and you don't have to ship your apps to us as well. You can host it on-prem. Okay, so this is lovely. But then coming back to the black boxes, these apps, the fabrics, the VNets, bridge domains, keeping them inside the system is great. We can monetize whatever we want out of it, but we also want to make sure that it's open. So that is something that I think we as a community are moving forward to. We try to make more things approachable to users. For example, if we have a fabric and it creates a bunch of stuff, how do you know what it really does? If we do not open the source code of these apps, you will never know what's going on. If you want to tune it up, if you want to change it and make it more akin to your needs, you need to know, you need to have a look at the code, maybe fork it and enhance it and create the abstraction on top of it. That is what we say. We're trying to break the black box and make sure that this is not something that you have to take or leave, but something that you can take and enhance, take and see how it works, take and see, maybe you can create an adapted version of it. So these apps that we showed you today we plan to open source them so you can have a look and see exactly what we're doing. That will help you to understand how to build apps on the platform. We want you to build apps on the platform. We don't want for you to blindly consume the resources that we have. You definitely can. That's probably the easiest way. Just get EDA and use the abstractions that we have. But we also want you to make sure that you feel comfortable writing tools on the platform. That is why we try to open as much as possible. And one of the toolings that help with that is the EDABuilder. That is a CLI that we created on the platform that allows you to build applications. It's kind of a CLI that helps you scaffold the application structure. So you don't have to do everything manually. It tries to bring you up to speed and show you what is possible to create such an app for EDA, right? Again, something that we try to make sure we do right is make sure the tools are there for you. The developer experience tools is very important to have. So we want you not to struggle, but have like good documentation, good tools, so that you can start writing apps on it. And as I said, the application is not just the script that configures, that takes in an input and configures BGP on the node. It's much more. There's API definitions. Everything is an API eventually. And when you define your new application, the API is part of it. You cannot write just some abstracted input and then be done with it. You also have these config and state scripts. You have normalization that your app can do. And that is very important for multi-vendor. I know I talk about multi-vendor quite a lot, but did not show it. It's common. For multi-vendor, normalization is key. When you have a data and you want for it to be multi-vendor compatible, you need to normalize it. Our way of dealing with BGP is different as our competitors do. So your script can normalize the data and present it to EDA in a normalized way. And you have a way to say how to do that. You can also, your applications can emit alarms. Actually, I did not show you alarms, I think, in this demo, but there is like an alarm list, and it shows you, currently it's a lot of alarms about transceivers not present because there's a virtual simulator that we use and they don't have transceiver emulation. But you can imagine that the Fabric app that we have, it can emit different alarms. Your Fabric can emit an alarm that says, yeah, I don't know, BGP peer isn't, BGP peer is not functioning, or something like this. So you have control over the alarms that the application can emit. There are also workflows. Workflows are very important for testing and the whole CI/CD paradigm. You want to be able to ship an application that contains a workflow. A workflow is a run-to-completion kind of application that starts with a step, goes to the next step based on fail or success. It either proceeds or stops. So the workflow can do a ping mesh or validating that your BGP peers are up. And again, this is something you can package in the application. The same tool that I just described, the EDABuilder, is used by our R&D as well when they write apps. So the Fabrics app was built using EDABuilder. They use EDABuilder to scaffold it. They use EDABuilder to publish it, to package it, push it to a registry. There's a lot of commands that help you package an app, push it to a registry, create a catalog entry. All that stuff we are trying to make it as easy as possible for you to start working with it. And it is an API-only system, not the API first, because I think we are past the cut line where API first was a good thing. Like nowadays, if you don't have an API, you probably will not have a product on the market anyhow. So it is API first, meaning that everything you can do through UI, through the demos that you saw that we leveraged, they all use REST API of EDA. So EDA exposes a REST API that your clients, your automation scripts, your orchestration systems will use. And of course, they will have the same power as the UI. There is no disparity here, so it's kind of transparent. What you can do in UI, you can do with the REST API, period. There is no difference between these two interfaces. And EDA will take in your REST API request, be it creating a fabric or creating a transaction, or maybe just creating an interface or taking the state out of it or listing fabrics. It's all a REST API call. And then EDA will make a transaction or get data back at you if you just used GET. which means there's a lot of API endpoints, right? Which means there's like over 100 of API endpoints for different applications. But how do we deal with extensibility? We just installed the Prometheus app, and somehow, what did we extend our API surface? We actually did. And to show you what happens when you have a system running and how you can check what APIs you have there, there is an embedded API documentation tool that's in the platform. So you don't have to hunt for APIs. You don't have to go through the PDFs that do not fit on your screen. You just click on the API documentation, and you will see the REST API in a Swagger format presented back at you. So you have on the left-hand side all of the applications, right? I'm scrolling through all of them. And this is the AAA application and its API. So there's gets, posts, patch, put, etc. For example, if I switch to Fabric app, I can look at what endpoints this app exposes. So I can, for example, create a Fabric instance through REST API. How do I do that? If I switched to the schema mode here, and I probably can make it even bigger. So this schema shows what exactly you need to provide in the API body when you create this post request. And here you see that the body of this request is actually exactly the same as the YAML file that we dealt with. API, version, kind, metadata, and spec. And in the specification, if you open it down, you will see that it has all these fields for body leaves, fabric selector, interfaces, something that you saw in the YAML, you have it the same way here. It's actually quite the other way. The UI is generated based on the schema. So there is always a source of truth for everything API related, be it UI or just REST calls. You deal with the same data. There is no difference at all. When you create and commit a transaction in EDA UI, there is a REST API call that fires off to the API server with this body. And you can open web developer tools and see exactly what is being sent and use it in your automation systems. But what is cool as well is that, as you can see, there's a clear separation between the API endpoints. It's based on the app. Once you install a new app, your API extends. You remember that we installed the Prometheus exporter. Now it's there. Before, the API documentation will not list it because we did not have it installed. Now it's there, and we can use it quite successfully. This is what the API documentation gives you. You can either use it through UI, like we did. We open up the question mark API documentation. We saw the REST API Swagger UI there. You can also use the Discovery API. That is something that OpenAPI v3 allows you to do. You can use the OpenAPI/v3, and it will give you in JSON format all of the API endpoints that you can use. And the third one is the community repository that we created. So if you don't have EDA installed for some reason, maybe, I don't know, you don't have time to install it, even though it's only 10 minutes, let's imagine that you are not having your laptop with you and you're on the phone, you want to check the API specs. You can clone this repository or open this repository. It will have all the links for all the specs. It is community though, right? So we do not publish it as at the same day as we release the the EDA software. So it might have a little bit of a lag while I update this repo, but we still plan to keep it going for the time being. This is what happened when we installed the API Prometheus exporter, right? So our API documentation did not have it. We installed the app, it pops up on the fly immediately. So you install your own app, you own something, and it will extend the schema right away. Now, what happens when you use the API? It's actually no difference to any other REST API. That is the beauty of REST, right? We've been using it for so long, so it's all the same. It's just REST. There is no magic. It's not even gRPC, so it's a very basic thing. But because the complexity happens in EDA, you don't need a complex management interface. REST will do just fine. So the way it works is that you have an API client. The API client, of course, needs to be authenticated. You need to authenticate against the Keycloak, that is our identity management solution that we use in EDA. So in Keycloak, you need to get the client secret of your EDA client. That is what authenticates the API client against the EDA. You get this from the keycloak, and this is all documented in our doc, so you will see how to do that. So you get the client secret. After that, you can request the access token. This token will be a typical OAuth token that you can use to talk to EDA. It has a lifetime, it expires, so you need to re-ask for a token. Usual stuff. That's all based on standards, open authentication. Then you have a token granted by Keycloak, you receive the token to your API client, and then you fire off your API request. That is as easy as it is. API request with an access token, you provide it to the EDA API server, and EDA API server will give you a response back. So that's actually it. You want them to continue doing your automation. If you have like a state system that constantly does API calls, then you will refresh a token or you will request a new one. It depends on how you want to get it done. This is the token request. The reason I'm showing this is because after the launch, when we all are refreshed, full with meat, we'll gather in the big room and we'll play with some EDA exercises. One of the exercises will be around using REST API, either through Postman or Python, or you can choose whatever client you have. And this is how you can get the token, right? This is the curl request that goes to the EDA URL, provides the client secret and client ID. Client ID is currently set to EDA, that is a hard-coded value. And then you also need to provide the username and password of the user that you act upon, right? If you have an admin user, the default one in EDA, you will provide it in the last two lines that you see. How to create a resource? If I would use my client here and I want to create something like a banner, something simple, this is what it takes, right? You have your authentication parameter in the header. That's all sorted, nicely done. And then in the body, that is what with the dash dash data, in the body of the request, it's just a JSON serialized data that you want to send to the EDA. It is the same data that you have in YAML file on the UI. So you basically can convert YAML to JSON, feed it in the request body, and off you go. There is no mental gymnastics. How do I do that? If I do this in UI this way, how do I do this through API? Same way, no difference. And this is how you this is where I explain what it is. So when you create, you have to provide the authorization, and the spec is just the big blob of data. Now the resource, I talked about this. Yeah, it's exactly the same. In the UI, you have this YAML file. In the API, it's just the same data, but in JSON format, because we deal with the REST API and the payload needs to be JSON serialized. But it's one-to-one match. There is one other thing that you can, of course, use in your automation system. You can use different languages, different clients. You can use Postman, you can use Ansible, you can use whatever you have. One of the exercises that we show to you is using Pydantic models. What Pydantic does for you is, instead of just taking this raw JSON data and feed it in your post request body, you can generate Pydantic classes, which will be your regular Python classes that you can use them to write your automation. The benefits that it brings to you is that you don't deal with manual JSON payloads because you don't validate them. For you, it's just a raw JSON blob. How do you know that it is modeled after the OpenAPI schema? How do you get these auto suggestions from the IDE? There is no validation. If you provide an ASM number minus 5,000, JSON will not complain, whatever you feed in. But you want to leverage these constraints that our schema has, right? You want to leverage the IDE support for hints and suggestions. That is why projects like Pydantic make it quite compelling for a lot of users to use, because you can take your OpenAPI spec, use Pydantic to generate Pydantic classes, and then these classes can be used in your Python automation to create objects. And one of the exercises that we have in our hackathon is exactly this. You will get a chance to write some automation using this Pydantic paradigm. So this is what it would look like, right? If I want to create the same banner, instead of saying that here is my JSON blob with raw string in it, instead I would say I can import a proper Python package or module, whatever they call it right now. And we publish these packages as a community repo as well, so you can just pip install it or UV add. And then you can just write my banner equals site info is the application that hosts the banners, site info.banner, and inside this class, you will be able to populate the fields. So instead of creating like a Jinja template for your JSON or just like raw JSON string, you can create something more akin to Python, more Pythonic way of dealing with these kind of API client calls. So here you will be able to see what fields can I use. Can I use a namespace in the metadata? Yes, you can. Can I use login banner inside my banner spec? Yes, you can, because it comes from the OpenAPI spec and it is generated for you automatically by Pydantic. Then you add it to transaction, commit transaction, and it's done. As easy as it is. And again, this is all simple because the hard part is done by EDA. You don't have to deal with the transaction. You don't have to reach to your nodes. All you have to do is create an object in the system, and the hard part will be figured out for you. We will also have some SDKs coming up. So the Go SDK is already there, but it was released just now, so we did not have any exercises based on that one. There's going to be a Python SDK as well. So you will be able to use the Python SDK with all the nice things like having a client already instantiated, being able to do commit and transaction stuff without writing it yourself. So these SDKs are quite fancy way and easy way to deal with our APIs. So to sum it up, this is basically an ultimate slide. The EDA system is something that I personally feel is quite interesting because there's a lot of things that make this system stand out from the rest of the pack. It has this extensible framework, right? It's a lot of things that are exposed to you are adaptable, so you can change them. You will allow you to look at the source code of the applications and make sure that you can build on top of the platform. It is multi-vendor by design, and we'll have some multi-vendor examples coming up shortly this year, because the power of abstractions can be way more powerful when you can deal with multi-vendor network, right? It's great if you guys will only use us for Linux in your data center networks, but we understand that you might have other vendors in your networks as well. So being able to use EDA for your multi-vendor part is even more beautiful, because that's where complexity multiplies when you have to deal with 2 different vendors or 3 different vendors. We have this great concept of transaction that is absolutely critical for all of us to leverage. We want to make sure that our transactions are reliable. You don't want to. Maybe you can even push on Friday night. Who knows? Maybe we are getting to it. The scaling numbers can be quite interesting with the system as well, because of the way we deal with the concurrent streams and committing it all at once and having a very lightweight database and using Git for our transactions and keeping it all in sync. So you'll be able to see how this can play well in scaled scenarios as well. And lastly, of course, the extensibility and automation, providing you with APIs that you can extend yourself by writing an application, making sure that the developers' tools are there for you is something that we want to make sure you all have and you enjoy working with the platform. So where to next? If you want to continue looking at this platform, if you find the ideas interesting and exciting, there are 2 things that I want you to take home with you. So first is docs.eda.dev. That is a website that will get you to the holy grail of knowledge about the platform, how to install it on a Mac, for example. So one of the systems is running on my Mac. You can install it on Windows. You only need to have 10 vCPUs, so make sure your company gives you a good laptop. And once you have this computer at your hands, the docs.eda.dev will explain everything you need to know. How to create all those VNets, how to install an application, how to build one with EDABuilder. It's all there. And we, of course, ramping up on the docs. The team that's building the docs is basically the product team that manages the EDA product. So we all take it quite personally, and we strive to write the best documentation possible. And lastly, of course, if you want to talk to us and to the community, I very much welcome you to join our EDA Dev Discord, so eda.dev/discord, and you will find another 500 enthusiasts already there. So we chat about the platform, how to create things. We are quite open, and we take pride in that. So thank you all.